Welcome back to this problem. I first tackled this problem in post 10, after which I gave an alternative solution to it in post 11. So do check those out. I also demonstrated in post 13 a false ambiguity this problem produces when we rely only on algebraic manipulation with complex numbers. Here I provide the clarification to that false ambiguity and perhaps the best approach when tackling complex number related problems. So I hope you enjoy it. We will evaluate the sum of the square root of I and the square root of minus I. This time around, let us handle complex numbers exactly for what they are, an extension of the real number system. The imaginary axis of complex numbers is displaced exactly 90 degrees from the real axis. So given their angularity characteristic, one way to express complex numbers is in their polar form. If we have just one unit of I, then its expression in the polar form would be e power I times pi over 2. The negative of I would be e power negative I times pi over 2. Taking the square root of I, we see that e to the power of I times pi over 2 times half gives e to the power of I times pi over 4. Analogous to this, the square root of negative I gives e to the power of negative I times pi over 4. In the complex number plane, this implies that the complex number vector is now 45 degrees displaced from the horizontal axis. The same would be seen for the minus I case, except this time we would have a negative 45 degree displacement from the horizontal axis. We can see from the green vectors orientations that they each have real and imaginary components. Graphically here, you can already see that the imaginary components of each vector are directed opposite to each other. This should already tell you what the correct answer to our problem would look like. But let's write out the analytical solution to this. Writing out our complex numbers in their standard forms, we know that e power I times pi over 4 would be the cos of 45 degrees plus I times the sine of 45 degrees. Cos 45 degrees and sine of 45 degrees both are 1 over the square root of 2. Which is more elegantly written as root 2 over 2. Analogous to this, square root of minus I would be root 2 over 2 minus I times root 2 over 2. Now returning to our problem, we simply need to sum the complex numbers together, this time in their standard forms. We can collect the like terms together. We find that the imaginary components cancel each other out, leaving us with the real components alone. Root 2 over 2 plus root 2 over 2 being the square root of 2. So both graphically as well as analytically, we have conclusively proven that the sum of the square root of I and the square root of minus I is in fact the square root of 2. For more math problems with solutions, go to mathofit.com. Once there, click on blog posts, choose a math problem and click show solution. You can watch the video explanation of the solution. Alternatively, you can come straight to the Math of It YouTube channel and check out all the available math videos to date. Like, share, subscribe, and tune in for more videos in time.